In this video, we revisit a decision-making notion from our first course, the tolerability of risk. In the public sector, there's often a desire to provide consistency in risk decisions. The Health and Safety Executive of the United Kingdom has done the most to formally develop the notion of tolerability of risk in an effort to provide that consistency in the UK. The Tolerability of Risk framework, as published in HSE's Reducing Risk, Protecting People, also known as R2P2, for the first time quantifies the boundaries between broadly acceptable, tolerable, and unacceptable risk, using the FN curve concept to do so. These boundaries would then presumably be used to make consistent regulatory decisions based on societal risk in the United Kingdom. We begin by revisiting the triangle that represents the increasing level of risk for a particular hazardous activity, measured by the individual risk and societal concerns it engenders as we move from the bottom of the triangle towards the top. The red zone at the top represents the unacceptable region. For practical purposes, a risk falling into that region is regarded as unacceptable, no matter what the level of benefits associated with the activity may be. Any activity or practice giving rise to risks falling in that region would, as a matter of principle, be forbidden unless the activity or practice can be modified to reduce the degree of risk so that it falls in one of the regions below, or there are exceptional reasons for the activity or practice to be retained, such as natural disasters that cannot be avoided. The blue zone at the bottom, on the other hand, represents a broadly acceptable region. Risks falling into this region are generally regarded as insignificant and adequately controlled. Risk managers or regulators would not usually require further action to reduce risks unless reasonably practicable measures are available. Risks in this region are comparable to those that people regard as insignificant or trivial in their daily lives. Examples include activities that are inherently not very hazardous, or hazardous activities that can be and are readily controlled to produce very low risks. The zone between the unacceptable and broadly acceptable regions is the tolerable region. Risks in that region are risks from activities that people are prepared to tolerate in order to secure benefits. In this region, it is expected that 1. The nature and level of the risks are properly assessed, and the results are used properly to determine control measures. The assessment of the risks needs to be based on the best available scientific evidence, and where evidence is lacking, on the best available scientific advice. 2. The residual risks are not unduly high and have been kept as low as reasonably practicable, the ALARP principle. And 3. The risks are periodically reviewed to ensure that they still meet the ALARP criterion. For example, by considering whether further or new control measures need to be introduced to take into account changes over time, such as new knowledge about the risk or the availability of new techniques for reducing or eliminating risks. We'd like to make these boundary concepts operational. By the way, the benefits for which people generally tolerate risks typically include employment, lower cost of production, personal convenience, or the maintenance of general social infrastructure, such as the production of electricity or the maintenance of food or water supplies. FN curves can be actual curves, or they can be policy-defined risk criterion lines. So let's consider how to develop an actual FN curve. FN diagrams may be used to depict at least 3 different types of information. One is a historical record of incidents. A second would be the results of a quantitative risk analysis. and the third would be criteria for judging the tolerability of risk. In this example, we'll assume we have the results of a quantitative risk assessment, as seen here in the table on the left. Each real or hypothetical event will have a predicted frequency of occurrence, designated as a small f, seen in column 3, and a predicted consequence, in this example the number of persons harmed, a capital N, seen in column 2. Thus, N is the predicted number of fatalities associated with the event, and its associated frequency of occurrence is expressed in events per year or annual probability. The raw data can be used to generate a small FN plot as shown here. Societal risk and risk criteria are commonly expressed in terms of cumulative frequency, or capital FN. To construct an FN curve, we sort the associated frequencies, the small f's, and the consequences, the n's, of all the relevant events from the largest consequence, or n, to the smallest. Then we construct the cumulative distribution function, the CDF, by summing the frequencies of the n and all larger n's as seen in column 4. So take a look at this breakpoint. It corresponds to 29 fatalities, and the curve in the table tells us there's a 1.5% chance there will be 29 fatalities or more this year. An FN curve like this characterizes actual societal risk objectively. The trick that remains is to define the boundaries between broadly acceptable and tolerable risks, and then the boundary between tolerable and unacceptable risks. Calculating a complete FN curve is very resource intensive, and it can be expensive as it requires analysis of all potential major accident scenarios. Criterion lines on FN plots have been suggested as a means to define risk zones or categories. The R2P2 defines one point with n equal to 50 and its cumulative probability equal to 1 chance in 5,000 per year, and if this point is placed on an FN curve and a line is drawn through it with a slope of -1, it provides a criteria comparison line. This point and its linear equivalent defines the boundary between unacceptable or intolerable risks and tolerable risks. In a similar policy-driven fashion, the boundary between tolerable and broadly acceptable risks can be defined. This figure shows the quantitative criteria for determining societal or individual risks. The location of the criterion lines can be determined on a project-by-project basis, or societal levels of risk may be determined for categories of risks by some higher authority. Conceptually, imagine that a 10% chance of one death and a 0.001% chance of 1,000 deaths define the societal boundary between tolerable and unacceptable risk, as seen in the figure. When we compare this criterion to actual societal risk, we see that the risk exceeds the threshold, and something must be done to reduce the societal risk. Risk managers must decide whether the actual curve must be below the criterion line at all points, or if they can tolerate some excursions above the line if these are balanced by points where the curve is below the criterion line. There's no universal agreement on this. The U.S. Army Corps of Engineers provides an example of these criterion lines in their levee safety guidelines, as seen here. The horizontal axis identifies N as the average number of lives expected to be lost in a flood event of a given recurrence interval. Recurrence interval is the metric of the vertical axis. The blue dashed line represents a societal risk line. Points above this line are unacceptable to society, while points below it are tolerable. The lower right represents an area where the loss of life is so high that it is unclear whether any probability is tolerable. There is no criterion dividing tolerable and acceptable risks in this diagram. Instead, there is a red dashed line that suggests that any risk in excess of 1 in 10,000 to any individual is unacceptable. It is noted that more discussion is needed on risks to individuals with a risk in excess of 1 in 10,000 annually. Decisions that are made strictly on the basis of FN curves are considered risk-based decisions. Decisions for which the FN curve is but one useful piece of information to consider are called risk-informed decisions. That are made strictly on the basis of FN curves are considered risk-based decisions. Decisions for which the FN curve is but one useful piece of information to consider